ratios and unit rates, we're going to take what we know and apply it to writing and solving proportions. Let's go over our vocabulary. A proportion is an equation that states that two ratios are equal. And cross product is the product of the numerator of one ratio and the denominator of the other. And here's an important note that refers to cross product. If the cross products are equal, then the ratios form a proportion. And while I know this sounds very confusing right now, once we go through our 4 examples, I know it'll be cleared up. Okay, so there are 3 different ways to solve proportions, and each of our 3 examples, in order, we'll go through every way. Now, what's good is that 2 of them are familiar to you. Let's look at this first one. Solve a proportion using equivalent ratios. When you see that, what that means is we need to solve for x by making equivalent fractions. So I'm going to start by rewriting what we have. And instead of writing in x, I'm just going to leave the numerator blank. Let's get a different color, make it easier to see. So here what we have to do is we know that when we go from 7 to 28, we are increasing. So we are going to be multiplying 3/7 by 1. And that 1, in this case, will look like 4 over 4, because 7 times 4 equals 28. So 4/4, because they're equivalent, it means that we're just multiplying or dividing by 1. 3 times 4 is 12. So here we have that 3/7 equals 12/28. These are proportional because the one fraction changes to the next in the same way by multiplying by 4. Let's take a look here. We have x over 48, which I said I'm going to refrain from including the x. Oops. And we have 2/12. And so what we're going to do is we're sort of working, well, not sort of, we are working backwards. Because here we have our variable, our blank space, on the other side of the equal sign. But the process doesn't change. To go from 12 to 48, we are increasing, so we're going to multiply 2/12 by a fractional form of 1. 12 times 4 equals 48, which means we're going to multiply the numerator also by 4. 2 times 4 is 8. So 8/48 is equivalent to 2/12. Here's our first example. Now, in our second example, we're solving a proportion by using algebra. Let's take a look. Now, what we have here basically is a one-step equation, which you first learned back in October. Let's take a look. What we want to do is isolate the variable x. So we have to ask ourselves, what is keeping the x from being by itself? How can we isolate it? Well, the x right now is being divided by 2. And the inverse operation, the opposite of being divided by 2, is to multiply by 2. So what we're going to do is multiply both sides of the equation by 2. And because we are working with fractions, I'm going to express my 2 as a fraction by putting it over 1. So what do we have here? Here, these 2's cross-cancel, and we end up with 1x. Over here, the 13 and the 1 were already prime numbers, but the 2 and the 4 can be simplified. 2 goes into itself once, 2 goes into 4 twice. So we end up with x equaling 13 over 2, but because it is an improper fraction, we need to write it in simplest form. We have x equaling 6 and 1/2. Okay, now here is the method that is new. As I said, the first two methods are familiar to you. This is brand new. Cross products. When we are talking about cross products, as the definition said, we are multiplying one numerator by the denominator of its counterpart, and then we're going to switch. So what does that mean? It means first we're going to multiply this numerator 4 by that denominator x. And it's important to realize we're not cross-simplifying, we're cross-multiplying. There's an operation going on. So what we have is 4 times x equals, and then this denominator multiplied by that numerator, 7 times 10. And then we'll simplify it to 4x equals 70. We want to get the x by itself. Since it's being multiplied by 4, we are going to divide both sides by 4. Because remember, in doing that, we have created a coefficient of 1 for our x. So we have x equals 70 divided by 4. 4 goes into 70, excuse me, 17.5 times, also known as 17 and a half. So here x equals 17.5. Now we are going to solve the second proportion the same way, but if you'll notice, we don't have a single number here. We don't have the x by itself, we have it in an expression. So while there is an extra step to happen here, there's an extra step here than we had over here to solve, everything is still familiar. We're taking skills you've learned in the fall and applying them here to this new lesson. The cross-simplifying means 39 times 7 equals this denominator, x plus 7, times 21. Now here's what I'm going to do. Because x plus 7 is an expression, I'm going to enclose it in parentheses and then put the 21 on the outside. So now what do? Well, we multiply. We have our 39 times 7. 39 times 7 is 273. Now here what we have to do is apply the distributive property. 21 times x is 21x, and 21 times 7 is a positive 147. And what we want to do, remember, is we are going to isolate this x. What's happening with the x? Well, it has a constant, 147, and it has a coefficient, 21. So what we're going to do first is negate the constant by putting negative 147 on both sides. Here, let me erase this and clean it up a little bit. That way we have more room. Let me just rewrite this. We have 273 equals 21x. All I'm doing is rewriting where we left off. Plus 147. We said that we are going to negate the constant first. That means putting a negative 147 on both sides. (273) minus 147 gives us 126. Here, this positive 147 and negative 147 make a 0. So we're left with 21x. We have one more step before our x is by itself. Since it's being multiplied by 21, we are going to divide both sides by 21. And when you do, we find that x equals 6. That's our final answer. And we have one more example. Word problem, I'll read it to you. 3 grades are going on a field trip. two buses will carry 60 people. Write and solve a proportion to find the number of buses needed for 150 people. Well, notice it just says to write and solve a proportion. It doesn't indicate that you have to use algebra, or that you have to use equivalent ratios, or that you have to cross multiply. So here is an example where you can use the one method that resonates most with you. It doesn't matter as long as you get to the answer properly. The only time it doesn't matter, though, is when the direction doesn't involve telling you which method to choose. Anyway, here, write and solve a proportion. When I see proportion, I know that we are going to have two equivalent fractions. We're writing a proportion, so that means that I right away open up my fraction bars, blank fraction bars. And you know what? Let's start with a fresh board. So two empty fractions. And what do we know? We know that two buses carry 60 people. We know, what's the other piece of information that we know? Well, what I'm going to do first is write in my units, because I want to make sure that as I'm plugging in the information that we have, my units or proportions are written correctly. So what's the other piece of information that we have from the word problem? Well, we know that there are 150 people going on the trip. What we don't know is how many buses we need. This is our task. Now for something like this, what I'm going to do is use the method of cross products. 2 times 150 equals 60 times x. Because I took this numerator and I'm going to multiply it by this denominator. Then I'm going to take this denominator and multiply it by this numerator. Please remember to use the equal sign in between. That's where a lot of students will make a mistake. They'll forget the equal sign and they don't know what to do with their numbers. Now we'll simplify. 2 times 150 is 300. 60 times x is 60x. Because we want to get the x by itself, we are going to divide both sides by 60. And we find that x equals 5. So in order to bring 150 people to the trip, we will need to hire 5 buses.